It's talking about infant weight from birth to a year, right? Babies grow really quickly. The first couple questions were just analyzing, right? At what age did the infant weigh 11 pounds? You should have 3 months. What was the infant's birth weight? You should have 7 pounds because that's exactly where the point is on the scatter plot. We would say that this is a positive linear relationship because it's going in a positive direction, and also you can create a trend line or a line of best fit. I found my 2 perfect intersection points right here because this is right here. The line goes through there, the line goes through this point, and that perfect intersection. My slope is, remember these increments are 2s, so it goes up 10 and it ends up going over 8. My y-intercept is going to be right here where the line crosses the y-axis. How are we doing so far? On track? So I simplified my slope to 5/4. I told you guys to skip number 7 for now. My equation, 5/4x plus 7, you leave this as a fraction. Did anybody have a different fraction than mine? Because remember, our trend lines aren't always going to be exactly the same. So your fraction might be different. Maybe you don't have a fraction. Maggie, what did you get?
I got 2/2.
Great. Which simplifies to 1. Okay, anybody get a different one than 5/4 or 2/2, which equals 1? No?
Wait, why did you times it by 18?
So then the next question says, how much will the child weigh at 18 months? So we can't use the graph because it only goes to 12. So I put 18 in here. Here's how I did the math for this. I'm going to take out my calculator. Right? I did 5 divided by 4 because that's what a fraction is. And then I multiplied that times the 18. And then I added the 7 pounds at birth weight. That's how I got the 29.5 pounds. Now, I know that our answers are probably very different, Maggie, because your slope was different. But if your slope makes sense with your trend line and you're using it accurately, then it's going to be counted correct. Right? If your fraction was 2/3, you would do 2 divided by 3 times whatever they want you to figure out as the x value. Add the y-intercept. Questions? How'd you do, Noah?
I think good.
Yeah, Emma, how'd you do? Good. Rylan? Thumbs up. Jalen? Okay. All right, let's move on to the next example about bananas. Bananas. All right, so we have our X, we have our Y, we have a blank graph that we need to actually label. So because my number of bananas is the X value, I'm going to write that as my X-axis title. Now, the number goes up to 5. So I have 5 here, so I can just go by ones. I did have a student in 3rd period go up by halves. That's fine. Whatever you want to do, as long as it's even increments and you can plot all the points. Weight in ounces is going to be my y-axis title. It's important that you label ounces because ounces and pounds are very different measurements, right? How many ounces are in a pound? 16, right? So we're talking about 2 very different scales. The highest number for weight is 20. I do not have 20 lines.
By 2s.
You went by 2s, perfect. All right, so we correctly labeled the graph. Now we just have to scatter our plots. Hopefully your scatter plot looks something like mine. And then I need to determine the direction and form. What's the direction? What's the form?
Positive linear.
Positive linear, good. I'm gonna fill that in these, right? I gave you the little hints of what you could choose. And guys, if it's nonlinear, it's gonna be a super drastic obvious. It's gonna be a wildly not straight line. Okay. All right, my line of best fit, my next step. Remember, I'm trying to get as close as I can to as many points as possible. Again, ours might not be exact, and that's okay. A check mark there. 2 perfect intersections. So I might pick, man, it's not really great. I'm gonna pick this one and this one, because that's as close as I can get to perfect intersections. This one happens to be right here on a point. This one's a little bit lower than the point, and that's okay. My slope is going to be up 4 over 1, right? Because this is worth 2, 4. And this is only worth 1 because our scales aren't the same. We have to pay close attention to the increments. Did anybody get a different slope for your trend line? Everybody in this room got 4. What'd you get? That's okay.
2.
Great. Wait, did you go up 2 lines or did you only go up 1 line over 1?
Well, I got like 16 over 8. And
Okay.
really like simplified.
Okay, that's fine. Again, as long as it looks like it matches your graph, that's a win to me. All right, my y-intercept is 0, 0 because 0 bananas is going to weigh 0 ounces. I asked you guys to skip number 6 for now. My linear equation is y equals 4x plus 0, or you could just say y equals 4x, whatever you are most comfortable with for the form. Of course, Carmen, yours would say 5x. Maggie, yours would say 2x. Did anybody have a different slope than 5, 2, or 4? Do we have any 3s out there? What'd you have, Noah?
4.
4. Brody, what'd you have?
4.
Okay. Evelyn?
5.
Okay, great. So how much would 15 bananas weigh? Well, I'm going to say y equals 4 times 15 plus the 0, because remember 0 bananas weighs 0. Y equals 60 ounces. What did you get for your answer, Maggie?
3.
Great. How about you, Carmen? 75? Yep. It should match, right? At this point, I'm just like, do you know what it means to find that? Great. Okay, last page. Pretty straightforward. I don't know if you guys got to this, but it's pretty easy. We're talking about the number of girls compared to the number of boys in a class, in 10 different classrooms. What type of relationship does this have?
Non-linear.
It's going to be no correlation. There's absolutely no rhyme or reason, right? This is just like somebody threw up confetti and just the points landed. Can we find a line of fit? Nope. You can't draw a line with this. There's no way to come up with any of that. Can we make predictions?
Yeah. No.
If I don't have a correlation or a line of fit, which means I don't have an equation, then nope, sure can't. And that was our practice for today. Questions? No? All right, I feel pretty good about this, guys. You're really